In this video, we're going to study some basic data structures in Python. They're important and many of them are unique. They're lists, tuples, and dictionaries. It's a kind of advanced data structures and the data types. So in the past, we learned the numeric and the strings, and today we're going to learn some more things. In Python, a lot of things are treated as a sequence. For example, string. String, they were like it's basically a text with the quotes, either double quotes or single quotes. Well, there is another type. It's called tuples. Tuples are used. Any numbers is using the parentheses inside the parentheses. They're very similar. Even you may not think that way at at the very first. So general sequence functions, operators, and methods. You're gonna have the no len for length. So then you put the sequence here, and then you can use the in, the keywords in is another one you can always use, and then you can use the indexing. You can directly use the brackets and then put the index. You can directly use, and then you can have the slicing. So basically, is you're having beginning index and end of index. So those is basically the sequence is going to create another copy of the sequence and taking the beginning index and end index and give to you, right? So, and also you can have the concatenating, which is the plus sign, and you can always find which index, particular index. If you want to find a one elements in the sequence, you can find the index for a particular index. And also you can use a for loop to iterate over a sequence. So you can use for and then one elements in the sequence. For index in a range of a length of word, that will be 4, right? So basically same as range 4, and this one will be while and the index is less than length of 4. So that's basically combined with this function and with construct a expression, so that's the sequence. Sequence is very important, and it's very often used. So the objective of today's lecture is introduce another two is lists. Lists are similar to the tuples in many cases. So we can create index and slice a list. Lists are mutable. Keep in mind the difference between lists and tuples are lists are mutable, meaning that you can change the element's value, while tuples you cannot change. String you cannot change. Use the lists methods. You can do append. You can add append, and you can do sorting. You can do reverse a list. Well, use the list sequence to represent even more complex information. So we can use NumPy, right? NumPy is, we're going to do this in the next few classes. It's one of our basic technology that we need to know for any data analytics. And then we can use dictionary. To work with the pairs of data. So you're going to have a pairs of data, which basically is name and value. So we're going to understanding the sorting algorithms as well. So the next slides is about the lists are similar to tuples. So the list actually is mutable. It's basically means changeable sequence of any type. You can create lists by simply just use a brackets. This means it's empty lists. And then the inventory, you can actually add elements. In this case, is just a string. And so the tuple, however, it's going to be inventory, and then this is going to be parentheses. The difference between those two is inventory for this one as a list, you can change it. And keep in mind, this is the pair of, so you have a beginning of the brackets and ending of the brackets. And here is the parenthesis, it's a pair. You can use the len, len function and in operator. So if health portion in inventory, then you're going to print out, because this is healing potion, right? Healing potion is in the inventory, so you are going to get a true evaluation of this expression. Therefore, you're going to print out this statement. And the indexing and the slicing will be the same, and you can also have concatenating. You can add the two lists together. And understanding the list's mutability means changeability. So the lists are mutable. The elements can be added, can be removed, can be updated. So here's an example. So we can assign a new elements or slice. So here's the list. We have inventory has this definition. Now I'm going to change the first one, sword, to crossbow. That will make it this becomes a crossbow, and all the rest will stay the same. All the rest will stay the same. And then we're going to suppose you want to just retrieve from number 4 to 6. So this is 0, 1, 2, 3, 4, and then this is the 5. So up to 6. So that means you're going to retrieve gold and gems, right? Gold and gems. That will be retrieved. However, you replace the whole 4 to 6 becomes this one. That means you are going to remove this 4 to 6. However, replace it with orb of future telling. So replace the two elements and 4 and 5 with the new elements. So this is the benefit of the lists. You will not be able to do this with the tuples. However, you can do it with lists. You can also remove, like you want to delete this one, you can delete. You can simply say del, delete inventory number 2. It will delete this one. Number 2 is gone, and you can delete everything from 0 to up to 2. So basically 0 and 1 will be gone. So in this case, you're gonna get rid of 0 and so you delete number 2. This one is already gone, so that will be the new lists. Then you get rid of 0 and 1, so that will give you the rest of those elements. So the lists methods included the following. It's not a complete list, it's just the commonly used one. So you can do append, means adding new values to the lists. Sort means you can sort the lists. The ascending is default order, and you can reverse the order of the list. So the very first one becomes the very last one. The very second from the top will becomes the second from the end, right? So the count basically returns the number of occurrences of a certain value. So it's basically count whatever the elements. If you have one element, it's going to count how many of them. Index is returning the actual index of a value, and insert is you can add a new value to a index, to a location. The pop means it's gonna basically it's gonna return the value at the position I and remove the value from the lists. So the pop means it's removing and returning the elements to you. Remove will simply just remove the elements, will not give you that particular elements. So pop and remove, the difference is that pop is will return that particular elements, while remove will not return anything. It's just do the operation of delete. When to use the tuples instead of lists, some of you may ask. So just keep in mind the difference. Normally tuples are faster than lists. Tuples are not changeable. So sometimes make it's perfect to create some constant values because they will not be changed. The rule of thumb is use lists over tuples in most of the cases. So most of the time you are using lists. Only a few cases you use tuples. Well, you can use the listed sequence. Listed sequence is you use sequence inside another sequence. So a list can contain a list or a tuple. However, the same thing, a tuple can contain tuples or lists. So they can mix to use. It's very, very flexible. So like here is the scores. You can have, this is a list, right? So you have a list, and then you can, inside the list, you have a tuple. You have a tuple. And that's it. So like the scores number 2 is actually 0, 1, 2. It's actually accessing this one. And then your accessing 0, 2 is the whole tuple. And in the tuple, you can referring 0 or 1. You can referring 0 or 1. So this is called multiple indexing. Multiple indexing. And you can unpack a sequence. For example, you have a sequence, you have a tuple right here, which is shimp and 175, and you can unpack them by just assigning a pair of variables. So the name will becomes shimp, and then the score will be 175. So you can print the name is shimp, and then the score is 175. Sequencing unpacking is automatically accessing each element of a sequence. The tuple is unpacked when you do assignments. So this is just one way of those operation. Assessing elements of a listed sequence. So suppose I want to retrieve a certain value. For example, so I have a score, which is a mixture of a tuple and the lists. And then when I do this for entry in score, every entry is actually a tuple. So this is number 1, this is number 0, this is number 1. Then I will get that entry, and then I can unpackage the tuple into score and name. It should be name and score, right? It should be name and score because this is name, this is score. So I think you can do that way. So sequence unpacking, automatically accessing each elements in the sequence as a result of assignments. Yep. And then for the variable reference, for the variable references, I think this should be actually, I should enable this. This should be it should be name and the tuple and the score. So that will make it correct. And then the next one, so for variable references, a variable reference to a place in the memory where the value is stored. So like when I have a statement like language equals to Python, in this one, the Python is actually a piece of memory. It contains Python, so roughly about 6 characters. And then I use the language pointing to this piece of memory. So the variable assignments can be initial, can be shared, and can be copied. So I can assign multiple. I can assign multiple references to the same piece of memory, and I can share the assignment. Like I can have A equals to B equals to this piece of memory, and I also can copy the value of the referenced memory. So in this case, we're gonna see shared reference. So I have in this case I have Mike, and then referring this piece of memory, which is a list, and I am going to change the number 2. So 0, 0, 1, 2. This one I changed to red sweeter, and then all of those the 2 references will actually be referring the same elements. It's gonna becomes red sweater instead of jacket. So that's you are actually sharing the same piece of memory. If one of them change the value, then all the rest will referring the updated value. So that's basically what's mean. Sometimes you want to avoid shared references, because if you are sharing them, one variable change the value, then you're gonna get those values. The best way to do that is you basically make another copy. You make a copy of those. You can simply just slicing everything from beginning to the end. So you make another copy for this particular variable. So in that case, you are changing the value of honey. It does not affect the mic. You see that? The listing slicing can create a new copy of lists and avoid the shared reference, but not for the listed sequence. Okay. And use copy, deep copy. You can use copy.deep copy to actually make a completely copy of every elements. So in this case, in the previous case, you have a listed lists, and when you are changing, you are doing the slicing to make a new copy. However, when you are changing one of those, it's still affecting this A. So sometimes to avoid that, you have to use the deep copy to copy everything, to copy an object. So with that, you're going to get a completely new different one. Okay. And NumPy it's basically means for numbers, right? NumPy is particular for arrays of numerical numbers instead of using the listed sequence. So we use NumPy, very, very convenient. When we want to create a 3x3 array or a 3x3 matrix, we can simply just do numpy.zeros 3x3, and all of them are integer. Well, if we're using the two-dimensional 3 by 3, we have to do like a 0 times 3, and then nested, and then we times 3, and then we have to assign like 1 by 1 to initialize them. So this is NumPy is much easier. We're gonna cover that later. And use the second part of the lecture is about dictionaries. So we have dictionaries. Dictionaries are mutable collection of key and value, or name value pairs. So you're gonna have a name and a value, or key and value. So like tuples and list dictionary is also another building type. It's also a sequence. You can think as a sequence. However, it's unlike the tuples and lists, dictionaries are not. They don't organize as a sequence, but instead is a pairs. The pairs will be. You should be able to still access like a sequence. The key and the values, the whole thing as a pair. And then you still can access the pairs as a sequence. Okay, works like the actual dictionary. Look up one thing to get another. You look up the key to get the value. Normally it's like that. You can create a dictionary. So dictionary use the curly brackets. Lists use the brackets, and tuples use the parentheses. So keep in mind those are the differences, only differences. A lot of times. So in this case, dictionary, you can have the name, and then you have the value, or key and value. Key and value, they are always a pair. So you separate them by use the comma. Create the new dictionary called the geek. Geek has two entries, two pairs. So you can call it two items, or two entries, or two pairs, whichever you prefer. Like each item is made up of a key and a value. In this case, the first one is going to be the key or the name. The other one is going to be the value. And you can create a dictionary by pairing values with column. That will be a lot easier if that's the case. So this is the dictionary. And then how do we use the key to retrieve the value? We can simply just go find the key, like 404. We can get the value, and or we can use uninstalled to retrieve what's the value. So it's just like a referring. So here, whatever the value is, you just use that as a key. So use the key as index to get the value. You cannot use the values as index to get the key. So it's one way. Use non-existing key as index will actually produce error. So the dictionaries do not have a position number, so it's not ordered. It's just like a regular dictionary. So how do we test if the key is actually in the dictionary? So to avoid this error, right? To avoid retrieving some non-existing key, you can use the in operator. You can see if a key is in the dictionary. If yes, then we're going to retrieve that value. So if the condition is true, then you can start to retrieve the operation. You retrieve the value from the dictionary. You can use the dictionary get methods, like geek.get 404. That will give you the value. Or you can use the get. It will get a non-existing key. It will give you none. So it will not at least give you an error. So it's just return some default value. So default value normally is a long. Add a key value pairs to a dictionary. That basically is increasing It's adding a new elements in the dictionary. So keep in mind, the dictionary and the lists, they are changeable, they are mutable. You can also update a value for existing key and value. So you can actually, for example, you can update a value of 44. You can just use geek 44 with a new value that will updating the existing value of a key. You can also delete a key value pair. To remove it, you just use that DL. You can delete it. So the selected dictionary methods, you can use has key or get key. Then you can has key is basically return true false value for based on if the key is in the dictionary. Well, get is just like what we have earlier. It's gonna give you the value of the key, so you're gonna use the key, and then you can use the default. If the default is not specified, it's gonna be a long, will be returned. The keys will actually return all the keys as a list. Values will return all the values as a list. Items will return the pair as a two elements tuple, a list of the tuple, right? So dictionary requirements, the keys must be unique, must be immutable. So keys cannot be changed. Values can be mutable or immutable. Don't have to be unique. So, and then the sorting algorithm. What is sorting? Sorting basically is an operation that reshuffle the items, reorganize the items into a groups according to a specific criteria or conditions. For example, what we want elements that in ascending order, meaning 1 is less than 2, 2 is less than 3, and so we order them like 1, 2, 3. That's actually a ascending order. Well, descending order is we put the bigger value numbers first and then decrease the values along the way. So the sorting algorithm, classic ones are bubble sort, selection sort, insert sort, merge sort, heap sort, quick sort. All of those are actually classic algorithm. You don't have to reinvent them from scratch. They will be covered in our algorithm class. Well, bubble sort is a one of the algorithm that actually select the smaller elements, so it's kind of pop up to the top of the lists, and then only use the comparison to operate on the elements. So it's a very simple implementation and easy to understand. So you will start from the beginning of the lists, compare every adjacent pair and swap their position if they're not in the right order. After each iteration, one element is needed to become the compared until there is no more elements left to compare or no more swap is made. So the complexity of the bubble sort basically is n squared. That means we are going to, if you have 10 elements, you probably need to compare 100 times. So the complexity means how many times we have to compare to make it in the right order in the worst case. Well, as a summary, in this class, we actually learned several unique data structures of Python. They are lists, tuples, dictionaries. They're very, very commonly used, and I hope you understand the differences. The lists and dictionaries they're changeable, they're mutable sequences. Well, tuples they're not. So that's the takeaways. Dictionaries is actually mutable collection of name and value pairs. In dictionary, you can have items as name and value, or key and value pairs. The keys are objects that used to as index look for other objects. And dictionaries, the keys are unique. The values are not necessarily unique. And also lists versus arrays. Python lists are very flexible and can hold completely different datas. Well, array has to be used the same data type. Arrays can be more efficient and take less space. And you're gonna use arrays. Consider the lumpy or SciPy packages, because those are for the computing data, for data analysis. Data types and the data structures. Data types are a well-defined collection of data with a well-defined set of operations on it, like int, float, strings. Well, data structures are actually implementation of a particular abstract data types like tree, graph, or lists, or dictionaries. Those are data structures. Building structures from the lists and dictionaries, etc. Right? So that's all for the lecture part for this class.